This video is going to go with the page in your packet that says the Bohr model meets the quantum mechanical model. And you're going to see a picture very similar to what's going to show up on here, and it's going to ask you to draw things in on that. So the Bohr model of the atom, he knew that there was a dense positive nucleus because he worked with Rutherford, who found that out. And in doing his experiments with hydrogen and seeing the light spectrum come out, he realized that there were these energy levels outside the nucleus and that that's where the electrons were located. So there was a first energy level and a second, and they go all the way out to 7, even though this picture is only going to go out to 6. And as you go farther away from the nucleus, each energy level requires more energy for an electron to be there, and that's why we call these the high energy levels, and this is a lower energy level down here. So what happened was we found out that this worked really well for hydrogen that only has one electron, but as you get to the atoms that have more electrons than that, this model started to fall apart, and then we had to develop a newer model called the quantum mechanical model. We still believe what Bohr found, that there are these energy levels and that electrons have to exist in the energy level. They can't be in between. But what the quantum mechanical model does is identifies sub-levels on each of these energy levels. There are 4 different types of sublevels. There's S, P, D, and F. And each energy level has a specific type of sublevels. Those sublevels then are also composed of spaces called orbitals. And those orbitals are spaces that can hold 2 electrons. When we draw orbitals, we typically draw them as a box. And then when we draw electrons in the orbitals, we would draw them as arrows pointing in different directions. And you'll get to that in a little bit. So the first energy level is very small. And Bohr found it could only hold 2 electrons. And that is still true. It only has 1 sublevel on it. And that sublevel only has 1 orbital. So on your notes, you'll draw in this box and you'll label it S. As we go to the second energy level, there are 2 different types of sublevels. There's an S sublevel, and then there's a different kind called P. And it's got 3 boxes, which means it has 3 different orbitals. When you go out to the third energy level, it has an S, and it has a P, and it has a new sublevel type called a D sublevel that has 1, 2, 3, 4, 5 orbitals in it. Then you go farther out to the 4th energy level, and there's another S, another P, another D, and then the last type, the F sublevel, which has 1, 2, 3, 4, 5, 6, 7 orbitals in it. And as you go farther out, they just repeat the same pattern, where the 5th energy level has an S, a P, a D, and an F. If I had finished this 6th energy level, it would also have a P and a D and an F. And if I had gone all the way out to the 7th energy level that exists, we would have those same 4 repeating again. So when electrons go into an atom, they have to go to the lowest possible location first. So they're going to come to the first energy level. They're going to be in an S sublevel because that's the only type there is here. But as we go to the second energy level, there are going to be rules that dictate whether it goes to the S or to the P.